average every rainfall. We have two methods to find the average annual rainfall. The first method we call arithmetic mean method. So it's like we can identify the rainfall depth in the in session in the catchment, and we just to plus together and divided by the number of the rain gauge. Okay, so based on this equation, for example, we have 4 stations inside of the subcatchment. For catchment 2, 3, 4, 5. So we have 2, 3, 4, 5. We can just take the average of the the rainfall inside of the catchment is about. So we got 33 millimeter. Okay, we have to choose the only rainfall inside the catchment area. Don't include outside the station outside the catchment area. Okay, the next method we call the descent mean method. Okay, so this one we use the area to be the weighting factor. For example, we have like this is the catchment area, for example. Okay, and we have the station of rainfall. Station 1, 2, 3, something 4, and something so 5. Okay, so we have 5 stations of rainfall inside and outside the catchment area. Okay, how can we draw the polygon area? The first step, we have to draw the connect line between each station. For example, we draw this, and we make a line perpendicular and equal length. We divide into this length, and this length is equal and perpendicular to the dashed line to draw the red line. Okay, and for the other between 3 and 4 we do the same. We can draw red lines and 1 and 4. And we can draw the the perpendicular and equal lengths divided by dashed line in equal lengths, and do the same this one. And if we do the precisely, this red line become at the middle of the triangle. Okay, we do the same for the other triangle between 4 to 5, 3 to 4, 3 to 5. Perpendicular and equal length. Okay, and we can draw the red line to the boundary of the catchment. So we can get the polygon for the P. Next we measure the area. For example, the area A. For the area A is come from this area. Okay. For P2, area A2, it comes from this area. Okay, and P5 this area. Then we should use this area to be the weighting factor, or we can say that for this area is mean equal to A phi to total area, something that is a weighting factor for A phi. Can this show the example how to do calculation? So you have 5 range station. Sorry. 1, 2, 3, 4, 5 station, and we make the polygon line. So the polygon line now is shown in this one. This is polygon line. Okay, this polygon. For example, for the station 1, the polygon line it is okay. This shape come from the A, B, C, D. So it's from the length A, B, C, D. Okay, and the area is this area. Okay, to get A1. A1. The next, for example, for the station B, or station 2, the bounded by KADE. Okay, KADE is KADE. So the boundary for the area is this area. Okay, for A2. Okay. Next, we can do some calculation into the numerical calculation. This one we have the five station of the rainfall. P1, 2, 3, 4, 5. Okay. And we can draw the polygon area between this station. So we got this line. Okay. So it means it comes from, we divide the dash line perpendicular to the dash line and equal length of dash line. Okay, so we got, and the next we do the measure the the area. So this part is about 0.22 cubic meter square kilometer. And for the P2 is this one. And for P2 is on this one. This is cover this area. And for the and next we time the the area with the observe rainfall with the area. So we got this number 22.2 from column 2 times column 3, and so we can do summation. We got this number 284.6, and when we divide it by the the area, so we got the depth, the average rainfall is 31.1 millimeter. For the next method, we call the iso-height method. And this look like the contour line in the from the at the beginning of this lecture to present the topographic map. And in this case, this line represents the depth of the rainfall. So this one it can be drawn from the point rainfall. For example, if we have a rain station, say this is rain station, and we can measure it's about 50 millimeter of rainfall, and this station 10 millimeter of rainfall, and another station measure 20 millimeter of rainfall. Okay, that is the 4 station of rainfall. So the next we can do some interpolation between each station. Between the difference between 10 and 15 is about 40. So if we want the contour interval is 10, so we can divide into 4 the 4 lengths, and start from 20, 30 and 40. Okay, and we can do the same for between 50 and 20. Now the difference is 30. Okay, so the 20, 30 and 40. Okay, and the next we can draw the contour line or iso-height between the the equal depth of rainfall. For example, we can start to draw the 40. So this is 40 line. Next we can draw the 30 and 20. Okay, so the blue the green line is show the iso-height, the depth of the contour line of the depth of the rainfall. To estimate the average depth of rainfall, we use the average between each line and multiply the area between each line and divided by the whole area. Okay, I'll show you next how to estimate. Next example to estimate average depth of rainfall from iso-height method. For example, this is for contour line 10, 20, 30, 40 and 50. 10, 20, 30, 40 and 50. In between 10 and 20 they measure the area enclosed. So this is about, let's say 1.59. So they measure the area in between is about 1.9 2.59, and the area between 10 and 20 and 30 is 2.24. So they measure the area between this is 2.24. Okay. And do the same for the other, the rest of the the iso height. So the next, they find the average between two lines. So this is the average. This one is 15, and put in this number. And this one is 25. And put in this number. And the next is this time column 2 with column 3. So we got like 15. So we got the 23.9. And next, the summation of the for every iso height, we got 255. And the final, we can estimate the P is equal to 255.2 divided by the whole area, equal to 27.9 millimeter. In this case, they don't do the weighting factor. They use the area times the average depth of rainfall. Or we can do another way. We can estimate the weighting factor using the enclosed area divided by total area.